Okay, so as we reach this section of the class, we just finished discussing the nebular hypothesis, which tells us where the solar system came from. And discussion that we'll start on now and in the next few videos is the planets, because that's what the nebular hypothesis gave us. So let's see where we're going to go from here. So this video is a bit of a planning stage one to sort of discuss what we'll see in the next few videos. So of course we have this graphic, which we've seen many times, and hopefully now at this point in your astronomy education, you can look at a graph like this and just say a lot about it. The sun, the small terrestrial planets, the big gas giants, the tilt, and just about anything else you can think of in there. This is what we got, so we'll sort of start talking about this a little bit here. Now the planets, of course, have these names here, and so what we'll do, we'll sort of go in order, and we'll talk about them. And there's actually a lot of stuff to say about Mercury and Venus, and I won't say very much about the Earth, because you know a lot about the Earth, you live on the Earth, but there is one thing I'd like to say about it in particular. Mars has some interesting aspects about it too. And Jupiter, Saturn are wonderful planets, and we'll look at them by name. But it turns out, in my opinion, the planets themselves really aren't that interesting unless you're just interested in really a lot of hardcore science and that kind of thing. Saturn, of course, has the rings. Jupiter is known for the big red spot, which we will sort of discuss, just visual things like that. But it turns out what's most interesting about these two planets are their moons. So I think that's where we'll very quickly steer our discussion when we get to those planets, is away from the planets themselves, but their moons are absolutely fascinating, in particular the ones of Jupiter. So we'll talk about those for sure. And I'll just have to confess then, as much as a big deal I made out of the name of this planet, and we said some things about Neptune as well, I just don't know much about them at all, and so I'm just going to leave them off the discussion list. If you ever have any interest in them, it's very easy to find whatever you'd like. And the overall guiding thing here for all the planets is it'd be really easy to spend a whole life and a whole PhD project working on them. But what we'll do, we'll just come up with one or two interesting things about all these planets, and that's what we'll discuss. And I guess I'll be the one who chooses what's interesting. That's sort of an interesting point there. But keep that in mind as you also review number 26, question number 26 on our list of questions, which says, name one interesting fact about each planet. So I think that's probably the goal of my lesson here. And as I send you off of Astronomy 101, whenever you hear the word Venus or Mercury or Jupiter or Mars, can you just say one or two interesting things about it that can, A, start a conversation, start your own lesson on it someday if you happen to be a teacher, you know, that kind of thing. So we'll just do that. I'll pick one or two interesting things from the planets, and I have them, and I'm genuinely am interested in them, and we'll just go from there. So what to do then? Because it can get a little boring, you know, if I just start to come out here, talk about the tilt and the rotation and the position. But what is actually kind of interesting is to compare them. So that's what we'll do. We'll sort of learn about the planets, a few interesting facts about each one of them, but we'll compare them because, boy, are they different. You might think, well, the terrestrial planets are all going to be similar and the gas giants are similar, but no such thing. They're very different and very interesting in that regard. So what we'll look at as we move on, there will be some common planet attributes that we'll look at. And so here's sort of the prerequisites for that. We'll always wonder about the magnetic field if a planet, because as you know, it has a magnetic field that has ramifications for solar wind protection, the core of the planet, it says something about its geology, all those things that you know about. So we'll always ask that about a planet. And if it has a magnetic core, or even if it doesn't, we will wonder if it has active geology. There's always a couple things about active geology that we'll pay attention to in particular. One is this big green circle here, because that's one of those subduction zones that we spoke about a few times, and the Earth has these, many of these. This, of course, is where this plate is moving down into the core to get remelted, while this one is sort of staying up above the core. And this here is where sort of the recycling of land and rocks can begin. Like if there was a crater sitting here on this plate and it gets moved down into the Earth here, well, it's going to get remelted and disappear, and you won't see the crater anymore. But that's what active geology is all about. And usually these are where volcanoes can exist, and also we can have things like sea floor spreading. So we'll sort of wonder about that as one of the planet attributes as well. Here's sort of a focus on just a subduction zone here. So here's the plate that's going under here to get remelted. This plate sort of either sort of stays where it is, maybe moves a bit more, but typically see the mountain ranges or volcanoes here, because as this plate moves below this one over here, there's definitely one affects the other for sure. That's sort of what a subduction zone is. And then as an example also of some of the common attributes, this is an example of a core section of the moon. We might wonder a little bit about the layers on these planets. Like if we started digging, what would we see? Some of it's a bit of mystery and all that sort of thing. We know, for example, like our moon may have had some trace iron in the core, because that's where the heavy elements might get differentiated to at some point. But that kind of thing is what we'll look at also. And also one interesting thing about the planets is their timing. We'll get this out of the way kind of quickly as we go, but as we'll find out with at least Mercury, that is the interesting thing about Mercury. So we'll talk about that. And what we mean about timing is just what you'd think here, the usual deal here. This is a greatly exaggerated view of the Earth here, and this is our favorite Cassiopeia way up here. Remember that W constellation on the other side of the Big Dipper. And so one of the things you might wonder is that if you were on a planet here doing your rotation and doing your orbiting, as you can see here, how long would it take you to spot Cassiopeia between night to night or day to day or whatever? So we'll look at timing as well. That's actually kind of interesting for these planets. And of course, the timing has a lot to do with things that you'll see in the sky. So this will come up from time to time also about things that we see changing view of the night sky. Of course, has to do with the planet timing and its motion. So with that introduction, let's start in on Mercury.